Welcome back. With this lesson, we're going to start a new section of the syllabus, which is called hardware. We're going to be looking at hardware devices and we're going to look at how these impact the use of a computer system. We're going to delve deeper into the intrinsic workings of a CPU before moving out to devices such as input, output, and storage. So let's begin this segment with understanding the role of a CPU in a computer and understanding what is meant by a microprocessor. Now, both these devices are quite commonly used. Most of the time, people just generically call them CPU. However, we're going to look at the difference between microprocessors and CPU and why they're important to a computer system. Let's start by looking at what hardware actually is, though. A lot of time, I find that students don't really understand what the term hardware actually implies. They know vaguely what it is, but there's some confusion between hardware and software. Hardware are the parts of a computer system that we can physically touch. If you can touch that particular part, you can hold it in your hands. That's basically a hardware device. Now, sometimes these hardware parts are inside the case of a computer or a laptop or a phone, so you can't directly touch them. But if you opened it up, you could touch them, and that's why they're called hardware. Software, on the other hand, are programs or code which can't be physically touched. They exist on a computer, so they're stored as instructions on a particular storage device. On screen, you can see the various different physical parts, from the power supply to the RAM to the processor to the motherboard to printers and many, many more. We're going to be looking at some of the common ones later on in the unit. So what about the CPU or the central processing unit? The CPU is sometimes called the microprocessor, at other times it's called the processor. It's the brain of a computer. It's central to all modern computer systems. Whether you use a tablet, whether you use a television, whether you use a smartphone, there would be a processor inside it. Now, these CPUs are often installed as integrated circuits on a single microchip. On screen, you can see a few examples. The M3 by Apple, Intel's latest i9, which can get up to 6.2 gigahertz without overclocking, and Qualcomm's Snapdragon 888, which is the latest mobile processor. Now, no matter what type of processor it has the responsibility for processing all the instructions and data that are input into the computer, so a result could be output. That's its main role. So it's going to take whatever data you throw at it via an input device or from a storage device, and it's going to do some calculations, do some processing, and it's going to produce some output, and that output is what's displayed for the user. So make sure you know the definition and its responsibility. The parts in bold are critical. So what's the difference between a microprocessor and a processor? Well, a microprocessor, as the name suggests, is a small CPU that focuses on one task alone. A CPU could do multiple tasks. It could run games, it could do word processing, it could do video editing. A microprocessor, though, can only do one thing. So they have a limited set of instructions. So their instruction set, their commands that are available for them to execute are fairly limited. Now, microprocessors are normally in the form of a standalone chip as well, and they have to be put onto a motherboard or a custom circuit board. Now, this type of specific task-based system is called an embedded system. And these range from traffic lights to fridges to washing machines to alarm clocks. Chances are that every type of electronic device will have a microprocessor embedded into it. That doesn't mean that it's a proper computer. However, it will run code which is specific to its hardware. Now that's where we're going to draw the line for this particular lesson because we're going to start off nice and easy. You should be able to answer the following questions. What is meant by hardware? What does CPU stand for and what does a CPU actually do? What is a microprocessor? How is a microprocessor different from a CPU? What is an embedded system? And you should be able to give a couple of examples of those. We'll revisit embedded systems in a lot more depth later on, but that's all for now. If you do have any questions, please get back to me. Otherwise, I'll see you in the next one.